All right, so this is the walkthrough of the review guide where I'm going to kind of summarize things. Be sure that you're checking your packet to look at all the different activities we did. This was a very long unit, and it'll take some review to get everything back into your minds, especially with all the days we've had off. It says, think of energy as a quantity that's always involved when there's a change in state of matter. When a substance gets hotter or colder or changes phase, energy is either transferred into or out of the system. One way energy is stored in a system is thermal energy, and that's, of course, the energy that is due to the motion of particles. As particles move faster, their thermal energy increases. As particles move faster, they tend to move farther apart from one another. Temperature is the measurement of thermal energy of the system. The first question says, explain why the alcohol level in a thermometer rises when it's placed in a warmer fluid. So the first thing is that the particles of the fluid, the warmer fluid, hit the glass of the thermometer. The second one is that the particles of the glass speed up. And hit the fluid, or let's just call it the alcohol. And then the third one, the alcohol particles speed up and move farther apart. And that's what's going to cause the level of the thermometer, or the alcohol, to rise up because the volume is increasing. It says, explain why the alcohol level in the thermometer falls when it's placed in a cooler fluid. So I'm going to do a 3-step process here. So number one, you've got the particles in the glass hit the colder water. They lose speed. Oops. The cold water gains speed. The fluid in the thermometer, the alcohol, hits the glass. Speeding the particles back up again. The fluid loses speed. And particles move closer together. This is really sloppy. So the volume drops. Okay, kind of a messy answer there. Explain how the Celsius scale was devised and why it's not appropriate to use it when describing the behavior of gases. And that was back to worksheet 1 and the different labs that we've done. Remember the Celsius scale? We've got 0 degrees Celsius is equal to the freezing point of water. 100 degrees Celsius is equal to boiling water. it's not appropriate to use it because this is not directly related to the speed of the particles. Where Kelvin is directly related to the speed of particles. 0 degrees Celsius, that freezing water, the particles are moving around. 0 degrees Celsius, the particles have come to an absolute stop. It says kinetic molecular theory. This theory describes all matter as being composed of tiny particles in endless random motion. In solids, the particles vibrate, but are locked into an orderly array. In a liquid, the particles are still connected, but are free to move around and slide past each other. And in the gas, the particles are moving very rapidly and are widely separated. It says, using particle diagrams represent samples of a cold and a hot gas. So here's my container. Here's some particles of gas. Here's a container. Here's some particles of gas. This one's going to be a hot gas, and this one's cold. So the difference between the two of those, and I'm going to use the length of my arrows, these are going to be moving quickly as they bounce off of things, where these are going to move more slowly as they move around the container. Okay, now we get into gas pressure. It says gas pressure is a measurement of the collisions of molecules with the sides of the container. A barometer is used to measure atmospheric pressure. A manometer is used to measure the pressure in a container. There are 3 variables, pressure, temperature, and volume, that are interrelated. So you should be able to predict the effect of changing pressure, volume, and temperature. Remember in class we used the popsicle stick? And we used positive. So whatever variable is staying constant, let's say that temperature is staying constant, if pressure goes up, volume is going to go down. So that's going to be an inverse relationship. Let's see, I'm doing another problem, and volume is staying the same. As temperature goes up, pressure will go up. So the relationship between these two is a direct relationship. Let's say that I'm doing a problem where pressure is staying the same, volume goes down. What does temperature do? It goes down also. So that's another direct relationship. So it says, explain in terms of collisions. Oops, let's get rid of that. Why the change has the effect you predicted. So anything that increases the rate of collisions with the sides of the container will increase pressure. Explain why one must use the absolute temperature scale to solve gas problems. Because 0 degrees Kelvin is no particle movement. All the other temperature scales, when you hit 0, whether it's Fahrenheit or Celsius, you still have particle movement on those scales. So the only one that is absolutely measuring temperature is the Kelvin scale. It says use factors to calculate nu, P, V, or T. Review worksheet 3, make a decision as to how the changes affect the variable you're looking for. This you should review. The problems that we actually did on Friday. And that's going to be pages, let's see. Pages 19 through 21. And you should have lots of examples on how to do those problems there. Suppose that you lower the temperature of a gas from 100 to 50 degrees Celsius. By what factor do you change the volume of the gas? So the first thing I'm going to do is I'm going to do my variables, and I'm going to just write them out. So I've got a change going on here. So the formula I'm going to need is I'm going to use the combined gas law, P1 V1 is over T1 is equal to P2 V2 over T2. So now I'm going to write my knowns down. Now, when you're writing your knowns, you have to identify which known is what. So P1, do I have a P1? I don't. Do I have a V1? It doesn't give me a volume. So I can actually use whatever volume I want. I'm going to use 100. My T1 is equal to, you lower the temperature of gas from 100, so that's going to be 100 degrees Celsius plus 273.15, 373.15 Kelvin. And then my volume, or sorry, my T2, my volume 2. Let me stop and redo this one. I need to write smaller. Too messy. Right, I'm going to do my variables over here. So we've got temperature that's changing and volume. So my formula is P1 V1 over T1. There's no mention of pressure changing at all, so I'm going to cross that out of my formula. Now I'm just going to do my variables. So V1 is, I can make up any volume I want, because it's not telling me a volume. I'm just looking at by what factor do you change the volume. So to make it nice and neat, I'm going to go do 100 ml. My T1, it's starting at 100 degrees Celsius. When I convert that to Kelvin, it's going to be 373.15. My volume 2 is what I'm going to solve for. And my temperature 2, that temperature is dropping to 50 degrees Celsius, which is, so that's going to be equal to 323.15. So now I'm ready to substitute my numbers in my formula. My volume 1, I'm going to say is 100. My temperature 1 is 373.15. My volume 2 is my unknown. And my final temperature is 323.15 K. So I'm going to cross multiply. And I'm going to cross multiply the other side. I need to isolate my variables, so I divide that by 373.15. Do that to this side. My units are canceling off, so my volume 2 is going to be equal to, so my volume 2 is going to be 86 milliliters. So by what factor was it reduced? And I'm just going to do an estimate here. So it went down by approximately 10%, if I'm rounding that to one significant figure, because this has got one significant figure. This would be 90 ml. So that's about 10% less than I started with. So by what factor? It decreased by 10%. Because that is 10% lower than this was. All right, suppose that 25.0 milliliters of a gas at 725 millimeters of mercury and 20 degrees Celsius is converted to standard temperature and pressure. What would the new volume be? I'm going to just draw a box over the top of this so I have a little bit more room. All right, so we've got a volume, we've got a pressure, and a temperature. So I'm definitely going to need to use, let me just change the color. Write down my knowns and unknowns. So my pressure is equal to 725 millimeters of mercury. My volume is 25.0 milliliters. My temperature is 20 degrees Celsius. I'm going to convert that to Kelvin. My pressure 2 is equal to standard pressure because it's converted to standard pressure. So I'm going to use standard pressure that has millimeters of mercury. So that's going to be 760 millimeters of mercury. My volume is my unknown. What would be the new volume? And my T2 is standard temperature, which I'm just going to grab the value in Kelvin so I don't have to anything to convert. So now I'm ready to plug the numbers in the formula. So it's 725 times my volume over my temperature in Kelvin is equal to just going to erase that part up here a little bit so I have my room. My volume 2 is what I'm solving for. And my temperature. So now I've got everything substituted in. To solve this, again, I'm going to choose the side that does not have my unknown, which is going to mean that that's going to be expanded out to now I'm ready to do the other side. And then isolate my variables. And V2 will equal volume 2 is going to equal 21.8 milliliters. I have to look for my significant figures. That's got 3, that's got 3, that's got 1. So my final answer has to be 20 milliliters. Because I can only have one significant figure in my answer. The study guide tells us that we have some density problems. Remember that density, let me change that color. Density is equal to mass over volume. So if you're given a density, let me pull up a problem. All right, so here's a problem I just made up. I'm going to make up a substance called lamidine, and it has a density of 23.6 grams per liter. If I have 2.4 liters, what is the mass? So I'm going to substitute the numbers in. The density is 293.6 grams per liter. If I have 22.4 liters, what is the mass? So in order to do this, I'm going to cross multiply and divide. So 23.6 grams per liter, really what we're saying is 23.6 grams per 1 liter. So now I can cross multiply. So I'm going to do this side first. And then I'm going to cross multiply the other side. Isolate my variable, get rid of it by dividing it by itself. My liters are canceling off, and I'm going to be left with how many grams. So this becomes just 23.6 times 2.4. And so the mass is going to be equal to 56.64 in the calculator grams. Significant figure-wise, I've got 3 in this one, I've got 2 in this one, so I need 2 in my answer. So the mass is going to be equal to 57 grams, and that would be my final answer. All right, now on to the next. Now, this review guide is not designed to tell you everything that's on the test. Things that are going to be on the test are similar to what you're going to find in quizzes. So at this point, I'd go ahead and switch and go to quizzes and try those out, because I tried to do a good representation of all the questions that are on the test. Good luck and have a good weekend.